All right, so this is a question out of 5.4. It's number 3. And it says the population mean and standard deviation are given below. Find the required probability and determine whether the given sample mean would be considered unusual. It says from a sample of n equals 65, find the probability of a sample mean being less than 25.2 if our population mean and our population standard deviation are 25 and 1.18. Okay, so we're going to do a couple of things here. So number one, y'all, we know that our n is 65. We know that our population mean is 25 and our population standard deviation is 1.18. Okay, we're trying to find the probability that the sample mean is less than 25.2. Okay, so I'm looking for the probability that x is smaller than 25.2. Okay, so what I'm going to do here is I'm going to use the central limit theorem. So central limit theorem is referring to when we're taking samples of a particular size and we find those averages, okay? And so when we're doing that in our sample distribution, the sample means has a mean equal to the population mean. So my mu x is the same thing as my population mean, which is mu. What is different, though, is my standard deviation of my sample means, okay? So this part we're going to have to figure out. So the first thing we're going to do is we're going to find our standard deviation for our sample means. And it's going to be equal to our original standard deviation, which is 1.18, divided by the square root of n. N in this case was 65. So I'm going to take my calculator, y'all. It's right here. Let me clear this out. So I'm going to take 1.18 divided by the square root of 65. And I'm coming up with 0.1464. So right here, 0.1464. Okay. Now, the next thing I'm going to do, excuse me, we're going to use this formula right here to find our new z-score. So we're going to take our x bar, and we're going to subtract our mu divided by the population, or I'm sorry, the standard deviation of my sample means, okay? So my formula is going to be z equals x bar, this is my x bar right here, minus mu x divided by sigma x. Okay, so let's see if we can figure this out. So this is going to be 25.2 minus 25 divided by 0.1464. Okay, so let's do this with our calculator. So I'm going to take 25.2 minus 25 divided by 0.1464, and I'm coming up with 1.37. Okay. So the z value I'm coming up with is 1.37. So remember, since we were looking for it to be less than, what I'm going to do now is I'm going to say I'm looking for the probability that z is less than 37. 1.37. Okay, if I think about this in regards to my normal curve, right, my normal distribution, it looks like this, right? I know here in the middle 0, 1, 2, 3, minus 1, minus 2, minus 3. The number that I'm really interested in here is that 1.37, right? And since we're looking for it to be smaller than, I'm looking for the area to the left, right? And so, y'all, I'm going to use my calculator for this. Okay, so if I'm going to do this with my calculator, remember, I'm going to go normal, CDF, and remember, we're going to have two numbers. We're going to have a lower number, and we're going to have an upper number. So I know my upper number is at 1.37. If I'm going all the way to the left, remember, I'm approaching the idea of negative infinity. So on my calculator, I'm going to use negative 999, right? And let's see what we can figure out. So let me grab my calculator again. Let me clear this. Second vars, normal CDF, negative 9999, comma, 1.37. And the probability I'm coming up with, I believe the directions say we're going to go to 4 decimal places, 0.9147. So 0.9147. Okay, so that's my answer that I'm coming up with. And then, let's see. When I look at the directions, right, round to 4 decimal places we did, it's asking me if it would be considered unusual. So remember, the only time it's going to be considered unusual is if the answers that I'm coming up with are smaller than 0.05, okay? And in this case, we're not coming up with anything smaller than 0.05, so we would say it is not unusual. Okay. So again, if y'all got any questions, let me know. You don't